And good morning. Here we are, ready for a beautiful streaming video of our Revit class, as you may see. And let's see if the chat is very nice. Perfect. So let me adjust this a little bit because I need to look prettier. Okay, very nice. So okay, yeah, perfect. Let's see. Yes, let's see what we have to learn today in Revit. That is very simple. So last week we have started more or less doing something about, I think we finished with floors, if I remember. And what we have to do today is we have to start exactly from there. We need to go in depth into floors. We need to understand exactly how floors work, how to change thickness, how to deal with floor placement. We will see that we can change the slope of the floor. I mean, there are a few things that we need to know about flooring. Then we will see even roof. So we will see how to create roof, and there are a lot of things that we need to learn about roof. So let's start. And let's see how many things you have to learn today. So perfect. This is my beautiful architectural template, and it shows me regular things. I'm working in metric system. I'm using millimeters also. So let's see this. First and most important, floor. Floor is the horizontal structure that allows you to close lower part of any architectural object. I mean, till here, nothing new. And how to use floor in Revit. This is extremely important because, first of all, the floor is nothing else than a closed shape that is extruded. And the shape itself is something that we are completely free to draw as we want. The extrusion instead is something that depends on the floor type that we select, and something that can be changed when we need to when we go to the properties and we change the floor type, as well as we can make our own customized floor thickness basically. And but then I will show you something extremely important, and that is related to how the floor is extruded. But let's start again by floor. So when I select the floor, you may notice something in particular, that is this. When you go to the floor, drawing tool that is automatically selected here is this weird one, the one that is called the pick walls. Why this? What is this tool here? This tool basically tells you that if you previously have already created walls, instead of retracing the shape of your walls, you can just select them, pick them, and Revit will use edges of your walls in order to give to make the shape of the roof, the floor that you want to create. So this is happening just by default. In our case, I'm starting by using no particular shape before, so I haven't created right now any wall, but this is why. Simply because I want to show that in general, to make the floor, you just need to select floor, go in your drawing tools, and you need to draw at least one shape. Let me zoom in. One shape that has to be closed. This is the only important thing. Shape that is closed also will be extruded, so thickness of your floor is something that is managed by the floor type. So right now mine will be a generic 150 millimeters thick floor, and if I click OK, I can go then into the 3D view, and I will see that I have made my beautiful, great looking floor directly here. Okay? So let's see a few more things that we need to know about making the floor. There are, first of all, it is true that when I make a floor, I have to make a closed shape, but it is also true that inside same floor, I can have more than one closed shape. And why this is important? This is extremely important because when I do a floor and I make a horizontal shape that is closing my building, I mean, in this kind of orientation, sometimes the floor is not only the one that is touching the ground, but sometimes the floor is the one that connects first and second level, or maybe second and third level, and so on and so on. And in order to go from one level to another, maybe I have to make a staircase that would pass through the floor. In order to make a staircase passing through the floor, what I have to create is, I have to create the hole that will let the stair going through. And the way that you have to follow this is very simple, and it is this. You make your first outer shape for the floor, and this will be like boundary of the floor. But if inside your floor you draw another closed shape, let me tell you, no matter which closed shape you do, can be lines, can be circles, can be, the only important thing is that the second shape is closed as well. And again, can be one, can be more than one, so you can also do these kind of weird things. So I'm just drawing several closed shapes inside my floor. Okay, so if I check outer shape, this one is the one that is going to give me edges of my floor. This part will be the one that has the volume, the material of the floor. In these areas instead, there are closed shapes. I will see nothing. I will make holes. Let's see if it's true. So if I make this shape and then I click finish, let's see if it's right. Boom! of course is right, and you will see that your floor will look like this. There is a horizontal structure that has these shape as boundaries, and all other closed shapes instead are converted into holes. So you can basically see through the floor, and you can have, let's say, like structures that are going inside that space, and then you can go from one level to another. First, slightly technical thing that you need to know about floors is this. In order to explain this particular aspect, what I need to do is I need to open the elevation view, because I want to show you the floor from the side and not from the top or in 3D. I open whatever elevation, and this is this particular aspect that I have to show you. If I zoom in and I select the floor, I can clearly see that when I draw the floor, and I was using level 1 to draw the floor, the top part, the top face of the floor is the one that matches the height of my level. Then the entire thickness is the one that goes below. And we have seen this because, I mean, we were just very few last week, so it's better to repeat it. And but what is important is that thickness of the floor goes underneath the level where you have created the floor. And this is something that you have to keep in mind, simply because if this is my ground, doesn't change anything. But if I go to my level number 2 and I draw another floor, so I draw this, and then I click OK, what happens here? If I go again to my south elevation, I can see that this is my level, and the thickness of the floor goes below. It goes here. So this is important simply for measurements, because if my level number 2 was at the height that is 4,000, in reality it is not that the free height of the room is 4,000, because in reality, if I go to here, modify, and I use the tool that is called measure, if I measure from lower face of the floor till flooring of my next level, I can see that the real distance is a little bit less, of course. So look, if I do this, I would like to make it straight, probably. Let's see. Oh, perfect. So I can see this. Let's measure it like this. Oh, so that remains. I can see that the height is 3834. That basically is the overall height between the levels minus thickness of my floor. So if I select the floor and I change it with another one, let's say this super thick wall, I will discover again that the top of the floor remains fixed as the top level, while the thickness goes underneath. And this is something that I have to keep in mind when I create my levels, because levels in reality are not free height that I have inside the room, but levels are the distance between each flooring height and the next one. And this is first. Second thing that I want to show you when you use floor is, let me show you how to use floors and how to correctly use the tool that is called the pick walls. That is very simple. First of all, if I want to pick walls, let me tell you, I should create walls before and just make random walls. But I make them in a certain way, that is, I make these kind of complex shapes on purpose, because try to redrawing these walls will simply take forever. Okay, and I don't want to retrace with line, with arc and another arc in here all my walls. So what I have to know is that that option that happens, that comes by default, that is called pick walls, technically works like this. You click floor. As you can see, each time that you use floor, default drawing option is pick walls. And the way it works is this: you click it, and if you are not that good in Revit, you will pick each wall one by one. And also you will move your mouse so that your mouse will be closer to the outer face of the wall, because if not, sometimes it happens that Revit will find the inner edge of the wall. So you will have the floor here and your wall that will basically fly next to the edge of the floor, and this would be a drama. I mean, this would be a mistake. Pick wall in reality works like this. You can see that all of your walls are connected together. They are a continuous shape. So pick walls works like this. You select it, you move your mouse close to one exterior face of a wall. You don't click anything right now while you press tab on the keyboard first, so that Revit finds the entire chain of walls, and now you left click, boom, and in one operation you were able to select all of your shapes that you have previously made with walls. And only now I click OK, poof, and I have created the wall below all my walls. Okay? Let's see one more thing that is extremely important. If you notice, I have made on purpose something that is wait a second, how many messages? Wait a second. Hi Marco. Ciao Marco. Okay. Perfect. If you don't have generic, what should I do? If you have no generic, look, when you work with Revit, you should check these. That is I select floor, for example. And then I have to check my floor types. If this is populated with some of floor types, it means that technically Revit works, but simply the library that you are using is different than the library that I am using. Which is the problem? The problem is when you select floor, let's say, you go to properties and there is nothing here. So if this is the situation, it means that now, after many months and many weeks of using Revit, you discover now that you have no installed library. If this is the case, you should simply pray or cry. No, you should simply install a library. And the way to install the library will be this. Let's see. And this will be also last time that I explain how to install a library, because I explained it since day one. But you have to do this. You have to go to Control Panel. If you go to Control Panel, you go to Programs and Features. And I'm telling you slowly so that you can do it and then you won't have any other issue. Inside your programs list, you find something that is called Autodesk Revit Content Libraries. You double click it, you click yes to whatever, and you need to click this big button called Add or Remove. You click Add, then takes a second, and perfectly from here you will choose which library you want to install. As you can see, I have US Imperial, US Metric already installed. I have the Indian one. I should have the Italian, exactly. I have Italian and the generic international. If you simply want to install a library, let's say the United Kingdom one, or the New Zealand, or the Belgium, or US, just put a check sign next to it. Then click Next, and then wait until the entire library that you have selected is installed. Then you close and reopen Revit, and magically. So for now, I will. Do you want to rush? Do you want to wish cancel? Yes, I will cancel because I don't have to do any of these. But this is how to add libraries. And then let's continue. Let's see what to do. So what I was explaining now is this. When I make a floor, you can see this. My walls are starting from the level and they are going up, while my floor is starting from the level and it is, click cancel, and it is going down. So they perfectly match their sides here, their corners. What is important is this. Look at these walls. If you notice, these walls are on purpose left as 8,000 millimeters tall. So they go way beyond which is my level 2. So what happens if I go to level 2 and I make a floor in here? what happens will be this. Look, I click floor. You can do it as you wish. I mean, I will just use the default option that is pick walls. And I press tab and then click. And then OK. And when I do this, Revit will give me this particular message that says, floor and the roof overlaps walls. And then it says, would you like to join geometry and cut overlapping volume? Technically, we will click yes, but I want to show you what it changes if you click yes or if you click no. If I click yes, what happens in reality will be this. Look, it happens that my walls are still going up. But if I select the wall, you can correctly check that my lower wall stops when it finds the floor. Then that question, basically where we have answered yes, has done this for us. That is, the floor has cut the wall that was super tall. It has removed the wall that was passing through the floor, and then the wall continues above here. If instead, when we make our floor and we click OK, and to this question we answer no, we technically make a mistake. That is, in this precise moment, we will have that the wall goes all the way from the beginning till its end, but it will go through the floor, and the floor goes through the wall. So there will be two volumes that are overlapped, they are overlapping each other. And this, let me tell you, will be 100% wrong. It is also something that in rendering will be, I would say, barely visible, but something that when we will make sections, so when we will see the structure and even the hatch of the floor and the hatch of the wall, they will be, even hatches, they will be overlapping each other, so the entire technical drawing will be 100% wrong. So when we make floors and we have that message, right answer should be yes. This just to tell you. Let's see what happens instead if we forget these, because if we don't do this particular operation when, so the precise moment when we have created the floor, unfortunately we can do something that would be not that good, but I will show you that we can do something similar. That is, at least just because there is a floor that is going on top of this wall, what we can do is this. We can select the wall, and then we have these two options that are, we can click attach top base, and you will say, but this is one button, why you said two options? Give me a second. But you can see this. You can click attach top base, and then by default, as you may read here, and I will highlight these, as you may read here, By default, you attach the top. So what it means? It means that if I click a wall, I click attach the top, and then I click a floor, what happens will be this. Poof! It happens that my wall is cut so that its top face, so that the height of the wall perfectly stops when the floor starts. But when I select the wall and I click this button, it's called Attach Top Base, I technically have a second option that is called Base. So what this means is that I can even do the opposite. That is, I can click attach the base to this floor, and in this case what Revit does is it will leave the top where it is while it will cut lower part of my wall, and it will stick the wall onto the top of the floor. And I can, have these combinations in between floors and walls. I can correctly trim just where they are overlapping the floor. And it happens only when you create the floor. Or I can attach the top, or I can attach the base. I will show you now another property of the floor, and I will show you also why knowing that you can attach the top of the base is extremely important. But first of all, I want to show you this. So let's delete all these things. Let's delete also this rectangle, and let's go to level 1. Sometimes we need to create a floor, or in general a structure that is not perfectly horizontal, but maybe we need to check to create something that is angled, so something that has a slope. Okay? And why this? Because maybe in our structure there is a floor that is horizontal, then it goes up, and then it goes horizontal again. In this case, what we should prepare before will be this. We should go to whatever elevation, and we should prepare a few additional levels. So if I have a floor that has a slope, maybe it goes from what is called level 1 to another level. I will call level 3, or let's call it level 3, doesn't matter. Okay? But then see this, that will be unbelievable. I go to my level 1 and I make a floor. I make it whatever shape, like these. But then I will change something that is extremely important. And if you see in your floor dialog box, beside boundary line, you can also find something that for us is extremely important, that is called slope arrow. Slope arrow means that our floor, instead of being horizontal, can be angled. And slope arrow works like this. We click slope arrow, then it is a line. We click from where we want our floor to start till where we want our floor to be angled. let's say I want the entire floor to be sloped. So I make this line from this edge till this edge. Okay? The way that this tool allows us to modify the floor will be this, and it will be very simple. I select, and it is already selected, this slope arrow, and I will read a couple of parameters that I can find inside properties. There are two extremely important numbers to work with. That is level at tail, level at head. That means right now I have a certain height at this point, that is the tail, and I have another height, that is this one, that is called head. So I have to choose how the floor is angled. So what I will set is basically this. I will say that the level at tail matches level 1. Then I say that the level at head matches level 3. Okay? And eye offset should be always 0 in this case. And I click apply. If I go to one of my elevation, let's say east one, sorry, I have to click also OK because I haven't finished my floor, sorry. But I will see this. I will see that my floor won't be horizontal, while instead it will be angled. And the edge where I was starting my slope arrow perfectly matches my level 1. The head of the arrow instead matches level 3. And in this way I have made a sloped floor. This is why, because there are certain cases when you need to make a ramp, so you can quickly do ramp in a more correct way by using floors. And I will show you these also. Look, I go back to floor level 1 and I will add this floor. Don't save anything. I want to add this, no, on this side. Want to add these, and then I go to level 3 and I will add another floor, but this time they are 2 horizontal floors. If I go in 3 dimensions, basically this is what I will get at the end. That is, I have the floor that starts at level 1. Then I have no, Sudarshan, I will never explain it again. Yes, I will explain it in a second. And look, I will create this, that is the floor that goes into level 1. This is the floor that is into level 3. And in the middle, I have the floor that goes from level 1 to level 3. But let me show you again. Look, first thing first is in your elevation, no matter which one, you need to have additional levels. So let me delete this one. Yes. Look, right now I have only level 1, level 2. If I want, I can also add more levels. Let's say I call it this one, and I call this level Marco. Yes. So see what I can do. I create a floor that is in level 1. So I go to level 1, I go to architecture, I make floor, and I give the floor the shape that I want. And it doesn't have to be rectangular, it can be whatever shape. So I can even make it like this, why not? Because if not, someone will think that maybe it works only if the floor is rectangular. Absolutely not. But first I make the floor. If I just click OK, what happens will be that the floor will be perfectly horizontal and it will match the surface of my level 1. What I want to do instead is this. Before clicking OK, what I have to do is just below boundary lines in my floor tool, I can see slope arrow. So I click slope arrow, then I draw from where to where the slope will be angled. And let's say I start from here and I go till there. When I draw the slope arrow in the properties, I can see these two parameters that are called level at tail, level at head. So basically what Revit wants to know is, in this point, that is the tail of my arrow, in which level this edge of the floor is placed, so at which height. And I tell, look, these matches level 1, but it matches, so there is no offset. This must be always 0. But then I tell Revit that the more I go and I walk, let's say, over this floor, the more I will go up, 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 till when I reach the head of the arrow, so this point of my floor, I will reach the level that is called Marco. So I select my slope arrow and it starts, so the tail is level 1, the head, so where the slope finishes, will be the level that is called Marco. And again, offset must be 0. And I click apply. I close so that I finish making my floor, and let me tell you, from here you don't see any specific thing, rather this weird cut. But if I go to my 3D view instead, I will discover that the floor is actually sloped, and it starts at level 1 and it finishes at the level that is called Marco. If I'm right, I can try this also. I can go to level 1 and I can add, look, another floor. And why not? Let's draw it like this. Very nice. Then make another arc. Very nice. And I will make a line. Oops. I will make this line. And I will make this line, because the floor must be always a closed shape. And this is a floor that is placed, as you may see, at level 1 without any slope, just a regular floor. If I'm right, by going into 3D, I will see that I have my horizontal, but just curvy floor that is horizontal. It perfectly finds the one that is sloped and it was starting at level 1, and then the floor goes up to level Marco. And if I go to level Marco, I can instead draw another floor with, again, whatever shape I want. But it has to be closed. This is the only limit. Okay? And if I go to my 3D view, I will see this. Now I have the structure that starts at level 1, then it goes up level Marco, and then it remains at level that is Marco. Okay? But why this is so interesting? This is interesting because we can use these information, so the fact that we are using several floors, and also the fact that we are using a sloped floor in combination with that particular aspect of walls that we have seen a second ago, that is called attach top base. What it means? It means this. If I make a wall and I draw a wall here, okay, see what I have. In 3D, I will have this horrible situation that is, I have only here the wall is perfectly placed on top of my floor. Then there is this wall that is a disaster because it has its starting point matching the top of these, and it has instead then this other floor that it's passing through it. So I can do instead this simple step, that is, I select the wall, I click attach top base. I want to attach the base, so I don't want to cut down the wall, so I click base, and then I select my sloped floor. So my wall will be adjusted like this. So not only attach the base works if the floor is horizontal, but even if the floor is sloped, you will see that my wall will perfectly match the angle of the floor. And this happens even if I have more floors to work with. What it means? For example, I can do this here, but this, it's simple. I can attach the base to that. And you can see that because the wall is slightly longer than the floor, this part instead keeps going till the ground. But then see this other wall. This is a wall that is intersecting at the same time sloped floor and the horizontal floor that is up there. So no problems. Select the wall, touch top base, touch the top, and select these. And you can see that here is still passing through. But I can doing it again, so with the same wall selected, I attach top base again, click base, click these, boom. And I can have multiple floors cutting the wall on its base. Okay? Marco, can we create a ramp from our surface? I will close the chat right now so that it will be just a monologue and you can't interact. Uh, the answer is so and so with the floor, because if we make a slope, we need simply to understand what we are creating. So let's say you want to do this. You make a floor. We make a floor that is not straight, so we want to make it curvy. I think this was the question. That is like this. We get these, then we have these, then we have that, and then this. So technically what happens right now is this. Look, this is for sure a flat, simple floor. But if we need to make a ramp that has this shape, technically right tool won't be using floor and using slope, because if I try, and look, this should be a disaster. If I make a slope arrow, what happens is that I should make an arrow that goes from here to there. Okay? And then I should tell that, let's say, this starts at level 1 from 0, and it finishes at level mark. And I click apply. Then I click OK. And then in 3D, I will get these. Let's see, how can I show you? Exactly. So, exactly. If I show you from an elevation point of view, I can see something that is not exactly what we need, because the beginning and the end of the ramp won't be flat, but they will be tilted, because when we use slope, we basically treat the floor as one rigid object. So technically it's like having a piece of metal or piece of concrete, and no matter in which shape we cut it, but we will angle in a rigid way the entire element. So if our shape is curvy, then it's like having a curvy element that is rotated. So technically, in order to make a ramp that is also curvy, what we have to technically use would be, but not today for sure, would be or the tool that is called ramp. Simply because when we want to make something that is round and at the same time is going up, in reality we are not using one surface and we are just tilting the surface, but a shape that is round and that goes up at the same time is a helix. So it is basically like a spiral that goes up. So it's not a planar surface like a floor. So we can do this in Revit, but for sure not with the floor, but we will see these probably next week, when I will show you stairs and ramps and railings. There are a family of objects that must be explained together. Is that clear? Yes. Answer is yes. Clear, Mark. Perfect. But main problem is this. You can't do this with the floor because the floor keeps the geometry rigid, and it keeps these faces as planar faces and not like helix looking shapes, like a spiral stair, for example. Then let's see something different instead. Perfect. Let's see another thing that is, I want to show you the roof. So let me delete this level, okay, and we'll need just these two levels. The roof, again, is something that you can create. First of all, it says this. When you just click roof, Revit by default will like to use which is your higher level. So it reads all of your levels, it finds the one that is on the top, and it will simply suggest that maybe you should place the roof in that level. And we will click yes for now, but for now I just want to show you something that is at the very beginning. The roof will look extremely similar to the floor. It has also same kind of drawing options, and again it has also the default option that is called pick walls, but not for these. We are limited in drawing roof just as the house goes. We are instead 100% free to choose the shape of the roof, because again the all important thing is that the roof shape must be just a closed profile. So let's just draw a very simple profile like this. That is a little bit weird, not that realistic. But what we need to start understanding is this. When we draw a roof, we can see that not only we draw a magenta shape, this kind of pink thing here, we can also see that next to each line there is this triangular symbol. Okay? These will tell you that starting from that edge the roof will be sloped, but we will see this in a second. Let me create the roof first, so that then we will start going in depth and we will understand how roof works. There is this. I just make this closed shape, then I click OK. Of course, in my level 1, I won't see anything because I said yes, make it on level 2. So I have to go to the 3D view and I will see the result of my shape. There is this particular roof here. So what we draw in reality is what is called footprint. That technically means the horizontal projection of the roof. Then, starting from each edge that we select, what Revit does is it creates a sloped plane with a certain angle that we are about to manage. Whenever these sloped planes are intersecting each other, so these intersect this one, this is where Revit creates this connection that separates elements of my roof. What is interesting is that we have a lot of tools to manipulate the roof, and we have certain options like we can adjust the overall and slope of the roof so that all faces will share same angle, so that it will be super pointy or almost horizontal. And this is something that you can do even after creating the roof, because you can simply select the roof. Then, once that you have created, you can go to the properties, and somewhere here into properties, you find the option that is called slope. And let me highlight it. Slope is here. This is a quick way to make the roof more or less angled. So if I click here, let's say, and I change it to 10 degrees and I click apply, all faces of my roof will be 10 degrees angled starting from the horizontal, so they will be very, very, very less sloped, but they work all together. If I make an angle, let's say like 45, that is very exaggerate, but then I will see instead that starting from the horizontal, 45 degrees goes up like this, and I will have my roof that is a lot more pointy, a lot more sloped. Okay? Instead, in Revit, you can not only change the slope of all faces together, you can go a lot more in depth, and you can make extremely complex, beautiful looking floors if you just realize something that happens while you are drawing the roof. That is this. Look. So let's hide this. If I go to floor, sorry, I said roof. So if I make a roof, I go to level 2 and I draw the shape that I want. Let's say this, let's say this, let's say this. Now, see this. As I said before, can you see that next to each edge there is this triangular symbol? This means slope, and this means that starting from this edge, there will be an angled surface that will go to this direction. There will be an angled surface that will start from this direction. There will be another one from here. Believe it or not, if you think about it, you can, let's see if I'm any good, you can imagine this. In here, there will be a surface that will go with this direction. From here, there will be a surface that will go this direction. In here, there is a surface that will go like this, here, like that, here, like that. And, believe it or not, if I make a roof, I can already guess that my roof is, let me change the color, but my roof is going to look like this. So I will make these, I will make that, I will make these, then these will go up here, these will go like that, and this will probably go like this. This is why, because from each of these edges there is a sloped plane, and also these lines that I have drawn are more or less shaky bisects of those angles, because all my planes are sharing same exact slope. This is not a limit in Revit, but this is something that instead you can manage, and while you are drawing footprint of your roof, you are also free to choose that if you select each individual edge, you have two completely different choices. There are edge by edge of your footprint. You can change individually the angle of the plane that will start from here. And this is first. But second, you can maybe say that these won't even be a slope. So what I will do now is I will just change angles, but then I will download a picture from the web that I will use as example in order to make a realistic roof like the one that we'll see into the picture. But at least start seeing this. I select this, and maybe instead of 30 degrees, I will make 10 degrees here. I will make 10 degrees there. I will make 60 degrees here, and I will make 60 degrees there. So what I have technically is now, from here, there will be a plane that is 60 degrees angled. From here, there is a plane that is 30 degrees angled. From here, 60. From here and here, there will be something that is 10 degrees angled. And if I click OK, my roof will look like this. Look. So it will have certain faces 10 degrees angled. It will have certain faces 30 degrees angled. But if I change my point of view, I will see that those other two faces will be perfectly 60 degrees angled. Okay? And I can make rooftops that have completely different kind of sloped values. Let's see now. Let's see if I can find a picture that is an interesting roof. Of course you can see it because I'm using another screen. If not, there is no surprise. I want this one. Exactly. So let's see this one. Can you see this roof here? And we will focus the attention right now to this particular roof, not this one, because this will be a little bit more common. Oh, this one, perfect, exactly this one. What you can see is that if I think the shape of this roof in floor plan, I can say that the roof will have something. Look, I also make walls so that it will look like a house. But if I draw walls of that house, I can see that the house is something that looks like this. Is it true? Yes, so it's top, 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 like a T-shaped house. So now, see this. First of all, I have, let's make it shorter. I have walls. So I'm also free to choose when I make roof and I go to my upper level. I am also free to choose this option, and this is extremely important to be selected, because look at also the original picture. You may notice that if this is the roof end doesn't really perfectly match the end, the top of the wall, but it goes a little bit beyond. And as well, you can see it here. Can you see that the roof exceeds the shape of the wall? And this is correctly done because the roof should protect the wall from the rain. So let's go back to this previous picture. Why this is important? This is important because if I, in Revit, if I use pick walls, by default, if I pick this wall, Revit will make footprint of the roof matching the top of the wall. And I don't want this. For this reason, before picking walls, can you see this option called overhang? This is the distance, that basically the offset, I will say, that the roof will take from the wall. Let's use this like at least 600 millimeters. So check now. I click my wall and I pick this wall, but the footprint of the roof will be 600 millimeters far, like this. So it is a shape that is basically an offset of the original shape of my walls, but it is 600 millimeters far from each wall. Then we need to see this again. Can you see that each of these edges has the slope symbol? If I keep my roof like this, believe it or not, it won't look like that. But this side will be correct, this side will be correct, these will be correct, this not. Because in here, in reality, I have not a sloped face that is going like this. Okay? With all roof tiles. Here, there is not this sloped face. In reality, in here, there is no slope at all. So, this is why not only you can select each segment here, sorry. Hey, Revit works. Okay. So not only you can select each segment, and for each segment you can define the slope angle, but you can also select the edge, and here you can even uncheck the option that you want to define the slope or not. And if you deselect the slope in here, the result will be not only phenomenal, but yes, I want to cut walls, and this will be what we have. Oops, there's another roof, sorry. So, this is an edge that has the slope. This is an edge that has the slope. This has slope. These and these have slope. This one, the one that was, I will orient the same way. But this one is the one that is where I have deselected define slope. Okay? And in this way, in here, the roof covers walls that are underneath, but it makes the roof flat at the end. Also, exactly like floors, if a wall, can you please do the deselect part once more? I don't know, maybe. I will show you again, but I will show you also another picture so that we can follow along. And look, see this. Let me find another picture first. Which one? These are all the same. This is exactly the same. This house here. Exactly. Let's see this one with the Tesla. So, can we have it bigger? Let me see. Whoa. Whatever happens in Danke. Okay, yes, whatever. Perfect. What? I close it. Okay, look at this picture. We have this wall, this roof that is flat here, then it is sloped there, then it is sloped here, it is flat here again. So how to make these? Look, let's draw it directly into level number 2. We click roof. We click roof. Then I draw the footprint. So I draw the shape in floor plan of my roof. And when I am drawing the roof itself, while I'm still into drawing footprints of the roof, I press escape once, or if you want, you can just click the select arrow, that's the same, but then I've not yet closed the roof tool, but now I can select these lines that are edges of my roof. And as the picture shows, this one, I need slope here, slope there, no here, no there. So technically I need slope starting here, slope starting here. I need slope starting here, slope here. I need no slope for this and for that. So I will select this and I uncheck the option define slope. I select these and I uncheck the option called define slope, so that when I click OK, my roof will look exactly like the one that I wanted to create. V-shaped here, V-shaped there, sloped here, sloped there. Okay? Does it work? Yes! Perfect! And let's see another thing that is now into the roof. Now there is only one more thing that I want to show you. That is, if you see, when you move your mouse next to the roof and you are able to select or you select your walls, or you prego Sudarshan, or you select your walls, or you draw your shapes as you please, there is one problem. There is not always all of these shapes are possible. I mean, not shapes that you have in mind are possible. So first thing that I can think is that you can make a curvy roof with this tool. You can just make a roof that has flat surfaces. But we can notice this. If we make our walls first, then we go to roof tool, but instead of clicking roof button, you can see a small triangle next to it. And if you click there, you can see that there are multiple other options. And at least today I will finish by showing you the tool that is called the roof by extrusion. And there is this one. Technically, roof by extrusion allows you to create the profile of the roof that you want, and then you will draw the profile, and this is why this is a little bit more tricky, simply because you will draw the roof not more from the top, but you will draw it from the side, and then you will extrude it by using the perpendicular direction to the plane that you have used to draw the profile. And in this way you can have completely different results. So for example, I will select roof by extrusion. I need to pick a plane so that I can draw it, but I will draw it from the profile view. So let's say I will pick this wall plane, this one, and now I will click OK. So now what I have to draw is something a little bit weird, because to draw a roof by extrusion I need to draw a profile that remains open, and this is tricky part, simply because thickness of the wall of the roof, is something that still depends on the roof type that you select. But to make the roof by extrusion, I will draw it, let's say like this, then I click finish, ready for this, and this is what you have. This is a roof that you have created by making one line only, so one open line. Thickness, so this is something that depends on the type of the roof, and I can still change it, because basically this is just a parallel shape that is applied once that I've made my open profile. What I can change is also, you can notice that my extruded roof starts exactly from the plane where I have created, and it finishes exactly to my last wall. But if I want, I can extend it, because when I select the roof by extrusion, you see at the beginning and at the end, you see these two blue arrows, and if you need, you can left click and drag, so that you can make not only the shape that you want, but you can extend the roof as much as you need. Okay? Last but not least, see this. When I have created a roof by using footprint, Revit has automatically cut my walls according to where the roof was. When I use roof by extrusion, this doesn't happen automatically, but it is something that I have to make manually in this way. So I have to select my walls. I need to click attach top base, like we have seen with the floor. Of course, I have to click the top. I click the roof and poof. Even if this is my own customized roof, it works and it correctly trims the top of my walls according to the shape of my roof. When you use roof by extrusion, there is only one limit. That is, you can't make shapes that have, or at least you can make, but then you can cut walls if the shape that you create are overhanging each other. What it means? Look, let me show you another example. I can make a roof by extrusion. I can pick a plane, pick these, level 2, fine. And I can even make a curvy wall if I need. Look. I can even do this. And again, this is an open shape. Then I click OK. I mean, I extrude it. If I want, I can even extend it more, but this will perfectly work with my walls. So I can still select my walls, attach the top to this roof, poof, and this is how my house will look like. There is only one limit, I was saying, that is this. If I make an open shape and I make something weird like this, roof by extrusion, pick a plane, pick this one for example, and I draw a shape like this. So what I have here is that this, and I mean, even, oh my gosh, this would be a disaster. Probably I can even do this one. Let's see. No, I can't. But then here the problem is that if I try to use attach top, I get this error message. And why this is happening? Simply because in this, that by the way is a beautiful design that I should copyright. But what is happening right now is this. In this particular point, let me highlight the issue. In this particular point, there is this lower face of the wall, of the roof, but there is also this lower face of the wall. So if I click attach the top, what is happening is simply that Revit cannot understand if these walls must be extended till they find this face, or it doesn't understand if it has to trim these walls so that they are attached into the lower face. This is why this particular shape can be modeled in Revit, but it won't technically work, because in reality I have these elements that are overhanging each other. So there is this kind of loop, and Revit doesn't understand how to properly cut the top of your walls. So this is the only limit that roof by extrusion has, and this is also last thing that I wanted to show you today. What you have to do instead as a homework will be this for now. That is, you should have done for today, let's see if I find it, and then I will check if there is also in the Google Drive. But for Revit, you should have made this homework, the one that was called first of all, why there is copy everywhere? Who is messing with my folders? So give me a second. And check this magic thing. I will delete this stuff. Yes. Skip. Perfect. So now I fixed my folder. Delete it. It's okay. So look here. For today, you should have done this homework here. But as you can see, this is one level only. So what you have to do is this, basically. And this is why, simply because next week we are going to talk about stairs and ramps, but mainly stairs. So I want you to prepare a model that will have already 2 levels. So what you have to do is simply this. By copying this into another file, so keep homework 2 file as homework 2 and save this as homework 3 before modifying it, you need to make a second floor on top of this floor plan, plus you need to add floors and the roof on top of your beautiful building. You are also free to choose to make second floor that is perfectly matching the shape of your first one. So you have 2 levels that are exactly the same. In that case, be so nice just to avoid using these as a door, but these should be a window, because if not, people will die. And then you will put the roof on top, and you can make the roof as you wish. You are also free, as I was saying, to make a second floor slightly different, like, just as example, you can make that this part will be the second floor, so that this part will remain in reality as a balcony. So you will put instead the door here, okay, and oops, no, and you are 100% free to make second floor as you want. Exactly, something like this. For example, these are examples, and you need to make second floor. You need to put floor at the ground level, floor in between, roof on top of your second floor. So you need to add levels and so on and so on. I don't know if you can hear it, but the bell rang. So if you have questions about the homework, do them now. If not, like and subscribe, I would say, and instead we will see next week. I will wait a couple of seconds to see if you have questions on chat. If not, you have 1 week to complete this homework. Is it clear? Let's see the chat. That is nice. Marco, my Revit is not working. I can meet you tomorrow. The answer is one and only, and the answer is, wait. Let me make it clearer. Schools in the whole country are closed to the public. You can't enter any school. So I don't know if this is clear. Maybe not. Maybe I will add this. Probably is better. No, students are not allowed to come at school. Absolutely not. And because the whole purpose of closing schools is to avoid contact between people. If I meet you outside the school, I mean, we miss the entire rule that the government says. So no, there are no private appointments in any case. Also, if we have questions, we can mail as low as you can, because I mean, probably, I mean, write me mail. Then if the question is easy, I can answer by mail. If questions are complex, maybe I will use your email in order to start next class by trying to solve your question. Also, how can we hand in the homework? Probably means how to deliver homework, like how to upload homeworks. For now, you don't need to. You don't need to send me, don't try to send me homework by mail, first of all. And what you have to do right now is forget about homeworks. I mean, not do them, but not tomorrow, because probably during the weekend I need to find a way, a clever way, to give all students the possibility to upload homeworks online, but I haven't figured it out yet. So give me a couple of days, then you will receive a message, or if you read daily the FDA secretary, I will ask lady to write there how to deliver homeworks. But for now, do them, because one day I will ask them and I want them immediately. So if someone will be late, then it would be just your fault, and you have no excuses. But I need to find how to do this. So do them, but for now, not. No, you have not to send me any homework. Okay? Okay. So also, Indu, if you have Revit that is not working properly, first of all, I would like to know what it means. is not working properly. So first send me an email describing what is not working, and then we will try to fix the issue by email. That would be a lot better. Okay? Perfect. No more questions. So see you next time. And again, like and subscribe.